My name is Manya. If you don't know me, I am the president of CruX UCLA. I'm a third-year neuro major, and NeuroTech is my passion. That is why I'm here. So I'm really excited to see you all.
Hi, everyone. Oh, that's okay. I'm Naomi. I'm the vice president of CruX at UCLA. I am a third-year cognitive science major, and I think computer brain integration is like my passion, like Manya said.
I guess I can go next. Hello, everyone. My name is Eugene. I am the project manager for CruX, and I am a third-year computer science and engineering major. And yeah, I just find NeuroTech to be really cool. Just the interaction between technology and neuroscience is just a really cool thing.
Hi, everyone. I'm Haniel. I'm a third-year neuro major. I'm the internal affairs for CruX. And like everyone else, I really love everything about the brain. So.
And hello, everyone. I'm Tiffany. I'm the workshop director for CruX this year. Currently a second-year bio major. And yeah, I'm really interested in the tie of technology with medicine. I'm glad we're all here for our celebration.
That's all of the UCLA officers.
My name is Jiling. I'm from the UCSD chapter, and I'm the president this year, and I'm a computer engineering and cognitive science double major. I also find NeuroTech super interesting, and I think that it's an intersection field that is going to explode in the future just because of all the advancements in both neurosciences and computers. And so I think it's a super exciting place to be. I'll choose Simon to go next.
I'm the project manager for NeuroTech at UCSD. I'm a third-year cognitive science major. And just like everyone else, I'm really into neuroscience and neurotech, and managing project to make sure everything is going well. Yeah.
All right, so I'm Andrew Wynn. I am from the UCSD NeuroTech chapter. And so my roles in NeuroTech at UCSD are being a communications officer, secretary, and webmaster. And so I'm actually in the club because I find neurotechnology very interesting, and I'm also interested in seeing its overlap with computer science. Jiling, is that all of us from UCSD?
I guess so. Yeah, I think we could.
Move on to the next slide.
Yeah, we can get started.
All right, so let's get started with the presentation. So starting off, NeuroTech at UCSD, we are affiliated with NeuroTechX. Our club was actually started recently in January 2020. Our faculty advisor is with Professor Vikash Gilja of the TNEL research group. Our club has connections with a neuro headset company called Wearable Sensing. Our club also participates in annual NTX student competitions, and our mission as an org is to bring together students interested in neurotech and to provide ways to get involved in the field.
Okay, so to kick off the year in review, here is a picture of us around the January 2020-ish range. We got to visit the Wearable Sensing company, and we also had our first kickoff event, and we had a nice headset demo from them, and also got to hear from our faculty advisor. Next slide. So also in January, one of the first things that we also did was bring NeuroTech hardware to the Hard Hack And at that event, we were able to work with wearable sensing and also 2 to 3 teams that were trying to use the headsets. And yeah, it was a lot of fun. There was a lot of free food. And unfortunately, we can't do that in the near future, but hopefully when we do get back to campus, we can continue doing that. Next slide. All right, so for some reason I have a lot of videos or pictures of Henry getting capped with NeuroTech devices, and these are just a couple of them. The first picture we see Henry at the CES conference, which is a international conference where a lot of tech companies come and show off their newest products. And this one, we got to see NextMind's headset where they can predict which box you're sort of looking at, so that if you're playing a game, you can hide these like invisible pieces of visual stimuli so that you can pick up like where the person is focusing. And like, oh, say I want to shoot something at this flying object, then it's kind of like using your laser vision to do that. So that was really fun. And then on the right, we see the wearable sensing headset. We're being trained to use it. So we spent some time there learning how to do that. Next slide. Cool. So in addition to playing with headsets and eating free food, we also had some events with grad students and CEOs. So on the left, you can see a panel of some of our awesomest COGS and ECE PhD students. And I think Ollie's here. So he's the one in the middle. Thanks for coming. And we also see on the right that we invited the CEO of Wearable Sensing to come and give a talk on entrepreneurship and how he's leading a neurotech company. So that was really cool to see too. Cool. So after we weren't able to meet in person anymore, we started this BCI series, and we did 4 workshops for this to get people started with BCIs. And that was a lot of fun. And then this fall quarter, we sort of expanded that to be a little bit more specifically neuro data technical, and collaborate with DS3 to do a neural data competition series. So this is the first neural data competition that UCSD has done before. And so this was also a lot of fun to host with DS3. So if you guys are, oh, cool. Yeah, I think that's it. And there's going to be some more information if you want to join that later. But now we'll just go into the project that we did for the NeuroTechX competition. So for the project, we did this thing called a motor imagery map. And the problem statement here is that we have paralyzed patients that have limited ability to move around the world. And like it's hard enough for us to like sort of be stuck at home, but like for them, it's even harder to sort of explore outside. And so kind of along the same lines, they don't really have the ability to control their computers in a very sophisticated way to be able to explore on Google Street Maps. So we wanted to build something to allow them to do this with their heads, with their minds. So this, by extracting motor imagery information, we can give them a volitional control axis and then control where they're trying to explore in Google Street Maps. Next slide. Okay, so our solution is to build a all-in-one motor imagery training app that outputs key commands. And this includes a whole series of things in order to train the user to use this headset and then be able to provide volitional commands through motor imagery, imagining left hand or right hand movement. And so these are some of the things that we did with calibration prompts, training, neurofeedback training, real-time signal and prediction visualization, an app launch, and also real-time decoding every 0.75 seconds or so. So yeah, we'll learn a little bit more about that with Simon.
Yeah, I'll be taking on the theories behind it. So if you guys been following for the past few workshops, you are probably pretty familiar with motor imagery, the neuroscience of it. It's basically the mu rhythm we're looking at, although you can technically include other rhythms as well, but we mainly look at the mu rhythm. And there's a characteristic drop in the mu rhythm when you are imagining a voluntary movement on the contralateral side, and it's often called event-related desynchronization. As you can see in the right-hand picture, the pink left hand is shown on the right hemisphere, and the gray hand is corresponding to the left hemisphere. And we place the electrode around the primary motor cortex to capture the rhythmic 9 to 11 hertz band. Next slide. And the experiment design, it was pretty crucial for the success of the experience. So I tried to make it as close to the original experiment as possible. So basically, the experiment design is based on the BCI competition 4 data set. They had this prompt trial procedure for the subject to follow through. And you can see on the timeline, each trial is about 8 to 9 seconds, and it's segmented into presentation, a visual cue and auditory cue, and followed by the imagery period, and finally a pause after that. So we introduced a little bit difference. So instead of 3 electrodes, we had 4, but it's still in the same 10-20 system. And basically 10 to 15 trials per either left versus right hand trials. And that's just for the calibration session. And for neurofeedback, it's a little more flexible. It's just to show you how well the model does. But for the calibration, it's usually 10 to 15 trials per class, and it's split evenly. Yeah, that's basically my size.
All right, so going into the interactive real-time app of our project. So basically what we have is, what our app looks like is that we have instructions for the calibration period, where the user has the option to go directly to neurofeedback. And then we also have we also have the calibration procedure in the image to the right of it to ensure that the model is trained to tailor for the user. And then we also have live data and predictions that can be seen in the data viewer. And then finally, we finally have the feedback procedure to report the model in action, which can be used to train the user to perform the motor imagery. And so here's our quick little video of how it works.
Yeah, so at the bottom, there's the live EEG data. And then at the top, there's a prediction value. And so that will be mapped to using the left or right key in the next thingy.
All right. So another feature of our app is the Google Maps navigation. So basically what it is that a prediction probability is outputted and produced by the model. And so once the probability surpasses a threshold key, once a probability surpasses a threshold, a key is pressed to indicate left or right movement on the map. And it will be demonstrated in this video right here. All right, moving on.
Yeah, so I guess like just from that previous video, we saw that the predictions may not there is like a bit of lag of prediction. And so there's still a lot of things we can improve about the project in terms of the machine learning pipeline and trying to make the real-time aspect of the app work a little bit more smoothly. So yeah, it's like an end-to-end project, but there's still a lot of things we can improve about it. Cool. Yeah, so that's pretty much our project in a nutshell. We also have a video overview with like more details into like data analysis and things like that. But we won't go into that here. I'll share the link in chat later. But I guess just to move on, we have a list of some upcoming events. We were planning to do something in week 2 for next quarter. So if you have any ideas of like what you want to see, like maybe a workshop of some sort, then please let us know. I have a link where you can also put your ideas for that. So this could be in relation to the neural data competition or anything. And then, yeah, we'll have a competition wrap up for winter quarter. And then we're also planning some more events. And we're hoping to grow our event like diversity. So next slide. If you were on the Discord, you would have already seen that we have project and officer applications that are opening up. And so you can apply for that here. So if you're interested in similar projects or becoming an officer and doing some leadership work, hosting some events, talking to company representatives or research faculty, grad students, things like that, this is a great way to expand your network. And also for next week, we are planning to have a study jam. It's going to be a pretty casual thing. Feel free to come to our Discord and study with us in the study jam channel. We might have some nice calming music, and we'll hopefully have each of our officers be there for a few hours each day. And then we'll share about like which classes we're studying for. So if you're also struggling with the same classes, feel free to come join us. And then also it's not too late to start in the neural data competition. So yeah, if you're interested, here's the link for that. And yeah, thank you for a fun 2020 NeuroTech at UCSD. I want to thank all the officers that made it a great year possible. Kevin, Zoe, Colin, Henry, me, I guess, Simon, Andrew, Darren, and Ryan, and faculty advisors, Professor Gilja and Professor Nguyen, for always supporting us and coming out to our events, and then all of you members as well. So thanks for making it a great year.
That was awesome, Juling. It's amazing to see all of the things that you all have done this year. especially as a new club. And it's so cool to hear from other organizations as well about different ways everyone has adapted to COVID-19 and continues to grow like people's skills and different ways to get people involved with NeuroTech. So we are gonna switch gears to CruX UCLA, woo! We've had a really awesome year. We've had so many new members join us. We've switched gears, pivoted a couple of the times over the past about what our focus is, and now we finally kind of solidified that. And the reason for this event and this presentation is just kind of to showcase all of the amazing things our members have done and kind of celebrate you. So I'm gonna try to request remote access and see if it's possible for me to change the slides, but if not, we'll just ask.
All right, Manya, you should be able to have remote screen control.
Perfect. All right.
Oops, sorry about that.
No problem. Naomi, take it away.
Awesome. So a little about CruX at UCLA. Our mission is to equip students with the knowledge, skills, and connections to contribute to the growing field of neurotechnology via 4 different aspects, which are intercollegiate brain-computer interface competitions, so the NeuroTechX BCI competitions, technical workshops, mentorship opportunities and coffee hours, and networking with academia and industry professionals. So throughout this presentation, we'll share a little bit about each of those things and how our members have interacted with each of those aspects of our club throughout the year and the quarter.
Awesome. So a little bit of background. We started in spring 2018. So the quarter before my freshman year. And a little fun tidbit about how to pronounce CruX. It is spelled CRU capital X to kind of mimic how NeuroTechX has a capital X at the end. And our founders, Vicky and Chris, you can see in this photo, basically wanted to kind of give homage to NeuroTechX, but also have a cool other name. So we are pronounced CruX and not CruX, as I think a lot of members might think when they first see our name. It's really awesome to see how we've grown. We've grown from a club that was primarily recruiting members to kind of work in Dr. Mehta's lab to becoming a club that was working on increasing neurotech awareness to the general population to now more of a focus on teaching members the technical skills they need to build different brain-computer interfaces. So it's really, really awesome. We have 6 board members today, over 100 general members, slightly fewer than that active members, I would say, but still a very impressive turnout for everyone. Oh, and so one of the really cool events that we did before COVID happened was this, we got to work with Dr. Spear, who's an assistant professor of neurology at UCLA, and he showed us, he gave us a demo of a P300 speller, an actual clinical version of it that he takes out on home visits to go see ALS patients and help them kind of communicate when they can't, and they kind of help improve the technology. So you can see one of our members, David, is the one trying out the cap. He is in basically all these pictures that we've ever used to promote the club. So thank you for that, David. It's nice to see you here. So basically he put on the cap. The P300 is event-related potential that comes up after you see something odd or unexpected. So essentially the speller flashes rows of light down the rows and columns. And so when David looked at a specific letter and was concentrating on that, over the course of multiple flashes, you can average what his brain waves and figure out which one he's thinking of. So it's a really cool way for people to communicate with just their brain.
Okay, so during the early stages of like COVID and like transition to online learning, we had researchers from the University of Cambridge come talk to CruX about minimally invasive neural interfacing and bioelectronics, as you can see on the slide, such as like spinal cord stimulation and biohybrid implants. And if you're curious to what these are or you want to know more, we have a private recording, so you can just reach out to us.
Another really cool event that we had in spring quarter was a talk by one of the co-founders of OpenBCI. He came and talked to us about his journey with like growing OpenBCI as a company, just like the general startup experience. He also did a quick demo of some of the OpenBCI headsets, and he also gave us like a quick preview of some things that they had in the works. And if you're interested in any of that at all, we also have a video of that on our YouTube channel. So make sure to check it out.
So when COVID hit, we've had to shift all of our meetings to online, but they have been a lot of fun, and getting to know everyone this quarter over Zoom has really been great. Our meetings have ranged from around like 80 people, which is super fun, to smaller coffee hour chats with like 1 or 2 or 3 or 4 people. And it's been really great to get to know people, especially like in these pictures when everyone turns their video on. It's super fun. We've also had mentorship meetings where people have gotten to know members of our club. And I am so grateful to my mentees because I had such a great time getting to know you guys. And I'm sure all the mentors feel that way as well.
And for coffee hours, I want to give a shout out to, I think there's Emma, Suraj, Raul, if he's here, I don't know. They've been showing up every week and I've learned so much about their lives and it's been a really fun time. So kind of a blanket statement to everyone, come to coffee hours. We're here to just talk, chill, complain about classes, talk about what goes on in our days and just kind of connect in an online setting.
So earlier this quarter, October 16, we had Dr. Eric Chudler from the Center of Neurotechnology at the University of Washington present to us, just come to like talk about like what the center is, which is a National Science Foundation funded institution that focuses on cutting edge research into neurotech in medical application. Dr. Chudler presented like various educational programs offered at the center for both undergraduates and postgraduates. I think there's one, like a program happening next summer. I don't know if the deadline has passed yet, but oh, and he also talked about neuroethics, which is the ethics of neurotechnology. So if you're curious too, and like you want to know more about this, or like we also have his contact information. So if you want to reach out to him, just let us know.
So our main focus this quarter, besides finishing up our NeuroTechX competition submission, was a introduction to neurotechnology with Python workshop series. And it was a really awesome 8-part program that gave all of our members an introduction to how to analyze EEG signal with Python, specifically NumPy and Matplotlib, and just the basics of coding for anyone who's more from the neuroscience side that wants to learn more about coding, and then also gave some basics on neuroscience for all of our students who are more interested in the technology aspects but don't know a lot about neuroscience. So the goal of this workshop series is really to merge lots of different topics and give students a foundation in neurotech, and we had so much fun teaching it. It was our first time doing it, so we definitely learned a lot, especially about how long it takes to teach these things. But thank you all for going on this journey with us. And yeah, it was really fun and really awesome to see you all every week and learn new things with you guys.
So apart from the workshop series, which was a lot of fun, Another thing that we did this quarter was finally wrap up our NeuroTechX competition submission. So last year, our competition, or for our first NeuroTechX competition, our project was basically turning an LED on and off by either relaxing or becoming more conscious. Then that would like basically change your alpha waves. And yeah, so we would read the state of the alpha waves and then basically toggle an LED based on that. And the point of that was kind of like a proof of concept for potentially like a smart home system where someone who's paralyzed could interact with a bunch of different devices without having to move as much. Um, and for that competition, we focused a lot more on the kind of like the technology aspect of it. We did have a good amount of like neuroscience um, in our project, but we also decided to use an app that came with the Muse SDK. And that basically gave us a good amount of the signal processing that we required. So for this year's competition, we wanted to focus a little bit more on the signal processing aspect. So we took our idea from last year and kind of expanded it to look at changes in alpha and beta powers compared to some baseline that we gather at the beginning of our trial, and then also some asymmetry in alpha powers between the left and right hemisphere. And Manya will go over the meanings of those in a little bit. But just to focus a little bit on our final product, you can kind of see like a basic diagram of what we had. So from the brain, we basically took the data and we processed it using a script in Python. And normally this would be done all in real time, but unfortunately due to the online nature of the competition, um, we couldn't really, or we found that streaming the data might be a little bit hard. So what we chose to do instead is basically take this pre-processed data and then feed it into a database, and that database would basically feed values into our app one at a time, and that would basically sort of simulate real-time streaming. And so the diagram that you see on the left is kind of just like a quick overview of what's happening. And then on the right, you can kind of see the two bits of data that we decided to focus on, which are the percent changes in alpha and beta powers, and also the asymmetry in alpha waves between the left and right hemisphere.
All right, so just a little bit more background about our project. We have the YouTube link somewhere, we can share it. Basically for our baseline, we had a person using the Muse headset relax with their eyes closed for the first minute, and we analyzed those EEG signals to kind of be used as a baseline for the rest of the trial. And then for the following minutes, the participant was more active and did some mental math. And so over the course of the trial, their beta wave powers increased while their alpha powers decreased. We also looked into alpha asymmetry values, which is a really interesting thing I didn't know about before we started the project, which basically there's some correlation that indicates that people with more left brain activity tend to have more flexible and adaptive thinking, and people with depression tend to have a slightly more right brain activity. So we looked into that as well, and we created a visualizer where you could see how your left and right brain activity was changing over time. And this is a really cool future direction for our project to take, because it could be used as a feedback mechanism to see, oh, how can we train ourselves to increase our left brain activity and decrease our right brain activity? Since there's not, unlike with motor imagery, you can't just think of turning like left or right, but there's no signal that you can consciously make to kind of increase your left or right brain activity. So it's a very interesting topic of research that I hope some of our members can explore in the future. So finally, just to wrap up, for a quick reminder to all of our members, now that you've completed the workshop series, we're really excited to place you all into BCI teams. All the applications are due tomorrow at midnight, and you must also sign up for an interview this weekend by then as well. So we're looking forward to reading your applications and hearing what ideas you all have. And that wraps it up for our side. Thank you, UCSD, for inviting us here, helping us develop this collaboration. And we're really excited to kind of move into a social networking side of this event.